have a wooden ball, an aluminum, brass, and lead. And they obviously have different masses. That was like 80 or 90, that was around 70, this was I think about 22, and this was like maybe 7 or 8 grams. Significant range. All right, so there's the top. You won't see that in this next view. In this case, we have the same length of pendulum. We're going to have the same pullback height. I'm going to use this to pull them all back the same distance and then release them all. So obviously the variable in this case is the mass. So pull them all back and release. So we can see that they're swinging essentially with the same period. Pull it back. All right. Let's move on to the next one. You can see that the length is the same and the masses are the same. All 4 of these are aluminum spheres. In this case, we're going to change the amplitude. That's the extent to which we're pulling these things back. Okay, let's try it from this side. 1, 2, 3. Same basic setup. We've got 4 pendulums mounted in a V-shaped suspension to keep them moving only in that one plane. And we're going to, this time, the mass is the same, 22-gram aluminum balls, and the pullback height is going to be the same with this. We're going to pull back the same distance. Keep it nice and parallel, and then sweep it out of the way. 1, 2, 3. All right, let's give that another go here, see if we can get a good shot here. All right, obviously the length makes a difference. Okay, this is the pendulum as a clock. If you haven't already figured out the period of a simple pendulum is 2 pi times square root of L over G. If we're interested in solving for a particular length, then we can square both sides of the equation. T squared equals 4 pi squared L over G. And then isolating length by itself, we end up with T squared times G divided by 4 pi squared. So that equation we're going to use there. We want to make a clock that has a period of 1 second. And so we're going to take that equation, and when we substitute 1 second into there, we've got 1 second squared times 9.81 meters per second squared. The second squared units cancels out, leaving us with meters. Divided by 4 pi squared gives us 0.2485 meters, 24.85 centimeters. So if we want a period back and forth of 1 second, we need to make it 24.85 centimeters long. All right, so the string is hanging right at the 50 centimeter mark. And so down here, we want this part down here to be at 24.85 centimeters. So from the 50 centimeter mark, this is 10, this is 20, 21, 22, 23, 24, and we want that center of mass to be right at 24.85 as best we can. So it's going to be right about there, and you can see it, that's right about the center of mass of the ball. Alright, so let's test it. So that's our length, and I'll get this out of the way. I want to make sure that the photo gate is intercepting as best we can the middle of the ball. So the beam of light shoots right across here, and we want that pendulum intercepting there. Alright, wake up the LabQuest. Set that up right behind it. So it's waiting for some data right now. We got a good reading right there. And we'll just give it a nice gentle swing. We don't have to have real dramatic swings. And you can see here that the period is 1.0077. So we're really good. We're really close. That was a really nice measurement. 1.006. So we're about 1/100th, less than 1/100th of a second off. Very good. All right, now we can do the same calculation for 2 seconds. And we end up with similar calculation. This time it's 2 seconds squared times 9.81 meters per second squared. Second squared cancels out. Divided by the 4 pi squared gives us 0.9940 meters, 99.40 centimeters. So this one is right up here. It starts up there, comes down the length. You can't see that black cord very well against the black background. And there's the pendulum right there. All right, let's take a look up here at the top. See the strings coming out right there. And we've got the meter stick starting there. Then we go down. And then we want this at 99.4. And you can see the center of mass is right at about 99.4. We are ready to go again. Discard that. Get the glare off. We're going to be looking right over here for the period. Try and keep the thing from hitting this. So a nice gentle swing. So there you go. 2.003. Excellent result again. All right. So what then if we're doing a 3-second period? So if we're doing this for 3 seconds, our calculations: 3 squared times 9.81 meters per second squared divided by 4 pi is there should be a point there, 2.236 meters or 223.6 centimeters. So that's pretty tall. 2.2 meters. I've got the pendulum attached to that clamp over there to the left, and then that rides over here to this other clamp, so I can adjust the height by just moving that clamp right there. The meter tape right there, the center of mass of the ball is right there at the base of that tape. So we're counting up from there. So there's 1 meter right there. And then we're continuing to go up. We hit 2 meters. That light's kind of in the way there. There's 2 meters right there in the center. And then up there at the ceiling, we're at 2.24 centimeters at about the same place where that string is dangling from the inside of that clip right there. Alright, so let's test it. Set it up so that it's going to intersect where the ball is. We don't need the tape anymore, we'll just push that off to the side. Alright, let's give it a go. Nice and gentle. Here, there we go, 2.9989, 2.9990, 2.9988. Very good. So with some very careful measurements, we're able to get a really nice pendulum. Very reliable. Alright, this is going to be the looping pendulum. On this side we've got a handful of washers here. Maybe about 15 or so washers. And on this side we've just got a single washer. So, handful of washers, single washer. I can put this over my finger. Let me do it this way. Let me put this over my finger, and when I let this washer act as a pendulum like this, see what happens. 1, 2, 3, it wraps around, so the washers get trapped, if you will. Let's do it on the rod up here. Okay, so it's going to act as a pendulum. 1, 2, this part's going to act as a pendulum. It's going to swing down, but as it swings down, this is going to fall. So, and it wraps around. Pretty cool. Let's try a different pitch. I'm going to go higher up, give it a little bit more swing. Let's see if it changes how it behaves. Pretty similar. Okay, this is our pendulum wave. We've got 25 golf balls, each swinging independently with gradual increases in their length. We've got 26.46 centimeters here with a period of 1.03 seconds. And our last one is a length of 1.58, a period of 1.58 centimeters, a length of 62 centimeters. We're going to start them all simultaneously. Huh?